Okay, so before Prezi, I was working for a small Hungarian VoIP company, and we were working on the service of the company, on the telephony service, and we were working on the website as well. And how we worked was the following. At first, we wrote some PHP code, worked for a few weeks, and after a while, usually I decided to make a release. So we did a deploy, which meant that I logged into the server, copied some files, changed some configuration files, did some database migration if it was needed, and changed some symlinks. And it happened sometimes that after a few weeks, someone called us from the marketing team that it's a bit suspicious that actually nobody registered in the last 2 weeks. What do we think about that? So we began to investigate, and we realized that we actually messed up the full registration process of the website. So we went back, fixed the code, deployed it, and it started from the beginning. So, and these are the questions: how can it happen that we deployed a version of the website where the registration was broken? Because we didn't have tests for the registration, or we didn't have any test actually. And the other problem was that how could it happen that we didn't notice that the registration is down? We didn't have proper monitoring for our system. Let me tell you another case. One of my colleagues was working on something, and after a while, after a few weeks of working, he decided to do a deploy in the middle of the night. I was on holiday at Balaton Lake, so I wasn't there, and we decided to do it. It mustn't be that hard. So went to the server. We already had a script for that. Went to the server and ran the script that was supposed to deploy the application. But that script wasn't actually designed for anyone to use it. It was a shortcut for me to make the development easier, and there were a few tricks that one should have known about that. This guy didn't know that he should have run it with sudo. He didn't run it with sudo, and the script with the restricted permissions could eventually delete the old version, but couldn't properly copy the new version. So it was one of the backend systems of the company. So the whole backend system broke because of this. And the guy realized that there is some problem with the deployment. So went to the website and checked a few pages. Unfortunately, pages that were not using the backend system, so they were working, even if the whole service was down. So decided not to experiment more with the deployment and went to sleep and decided to wait for me until I come back from holiday and do this stuff together. So fortunately, my children woke up at about 5 a.m. and I checked if everything is fine on the system, and I realized that everything is far from fine at the system, so I had some time to fix it. And what is the problem here? The problem is not that that we had a script that was not well designed, and not even the fact that this guy didn't realize that there is a big problem. The biggest problem was that we didn't have alerting for the fact that the whole service is down. I love this kind of stories because I think these stories are part of a way of improving our delivery pipeline. These are very important steps because in this case, who was responsible for creating a proper development pipeline was actually me. So hi, I'm Torok. I work at Prezi now. I'm a senior backend developer with some sysadmin background. And what I'd like to talk about now is the continuous delivery pipeline of Prezi. So if we go through the steps of the pipeline, it's pretty simple and pretty straightforward. At first, we write some code. We push it to the revision control system. Then we test it. We use Jenkins for testing. I will talk a bit more about that. And after that, we go to deploy our product. We have a separate application, web application for that. And eventually, if it's deployed, we go and check the dashboards. We check the graphs if everything is fine. So that's all. And if it turns out that something is not fine, then we go back, change the code, fix something, and test and deploy again. So let's take a look a bit in details. So at the beginning, Prezi was using Bazaar for revision control, and we used feature branches, which meant that a developer began to work on a feature, on 2 months long feature, created a branch, began to work on it, worked for 2 months, and after 2 months, he wanted to merge it back to the master. But merging back a 2-month-old branch is a pain, and not everyone can do it. Who is the person who usually can do it? These are the senior people of the company. So after a while, as the company was growing and we had more and more feature branches, more and more developers, after a while the senior people didn't do anything else than just merging other people's branches. And it was very annoying having these huge merges. So the company decided to get rid of these feature branches and go for small commits. So from this point on, everyone was committing to the master branch, which was great because we didn't have big merges. A 2-day or a 1-day old branch can be merged by anyone, by the original author of the commit. So it's not a problem. But there was a drawback of this, that the fact that the senior people were reviewing, were merging the code, it meant that they were also reviewing it, and it was very useful. So from this point on, they didn't do proper code review. And if I imagine myself having a 2-month-long feature, and after I have to commit after 1 day, what can I commit? How can I commit a half-done feature to the master branch, not breaking everything? And this is where the feature switches come to the picture. A feature switch looks like this. In Python, in our case, we have the switch word symbol, and we can check if a shiny new feature is active or not. If it's active, then the new code will run. If it's not, then the old code will run. So this means that when I begin to work on my feature, I create this feature switch, and I protect my new code everywhere in the code to make sure that the old code won't break. But when I'm done with my feature, I can just turn the feature switch on, and my code will come alive. And there is another thing that is useful with feature switches, not just supporting the continuous delivery, but for releasing feature for less people. So for example, I can say that I'm done with my feature, but I don't want to turn it on for everyone because it can be buggy. So because of this, I just turn it on for myself, for the people of Prezi, only for 1% of the people or for 50% of the people. So in our case, the feature switch is stored in a database. It has a JSON representation, and it contains a name, the shiny new feature, and a list of conditions if it's turned on or not. So, and there was another thing we faced too, was that we had, when the company began to, the people began to work in the company, they began to work on one code base. We had one big project, a Django application, and everyone was working on that. And after a while, it was a problem because we had more and more people, and even if we have very smart engineers and they take care about maintainable code, sometimes they do bad decisions, or sometimes they just don't properly understand of the meaning of a directory structure or something. So a code necessarily becomes messy after a while. And after a while, we didn't have anyone who could actually oversee the whole application. So we decided to separate the application to separate small repositories. But this was a problem because with this we began to face with operational overhead, because the Bazaar repository was operated by us. So there was a server, we had the Bazaar repositories there, and we had more and more people, more and more repositories. There were problems with the server, and we thought that after a while we will have to be able to scale this up, but we didn't want to deal with this. We didn't want to take care about the revision control system. We wanted to take care about our stuff. So this is why we decided to move from Bazaar and move from our own service to another service. This is why we moved to Git and to GitHub. So after we migrated everything from our own Bazaar to GitHub, then we didn't need any more operation, and it was great. We were using GitHub for a while, but having and not having the code review was always a problem. So now we decided to go for pull requests, which is a very good feature of GitHub, and with this we can review all the code we want to push into the master branch. So how does it look like working at Prezi now? A developer gets a 2-month-long feature. It's broken down to 2 days tasks. So I create a branch. I began to work on that. After 2 days, I submit a pull request, and someone will review my pull request. And if it's allowed, I get a +1 or the thumbs up. I can merge it to the master branch. And after it's merged, then we begin to test it. So I don't know if you know Jenkins. In one sentence, Jenkins is a huge Java application where you can define jobs. The jobs can be triggered by external resources like a GitHub push or another job in Jenkins, and with this we can create a chain of jobs. And a job can do anything, but basically most of the time they are shell scripts in our case, and they do testing. So this is how Jenkins looks like. So as you can see, everything is green, which means that all the tests are green. I don't know how this could happen. I think I didn't scroll down enough. But these are separate jobs, and and after a git push, these jobs come alive and begin to work on something, and they think that they are doing is different for different services. But they usually have the same structure, which is the following. We have a GitHub push, and then a special job, a flow job comes alive and does the following. At first it builds the application, which is, in a case of Java, it builds the jar file. In Python, we create the virtual env. So actually we create the environment for testing. Then we run the tests. We have a lot of tests, unit tests, functional tests, integration tests, in the repository. So we run the tests, and if all the tests pass, then we deploy our application to our test system, the pre-production system. And this is useful because here we can do UI tests, which is basically clicking on the browser. We have a separate job for that, and an application begins to click on the website. So we have more than 3,000 unit tests in one of our biggest Python application, more than 300 UI tests. We work more than 100 slaves, Jenkins slaves, and just now we began to experiment with Docker containers to make the testing environments more separate from each other. Okay, so if you look at this flow, we can see that there are several steps, and any of the steps can break. If a build breaks, or the test breaks, or deploying to production, to pre-production fails, then the whole flow will fail, and the application cannot be deployed. So if it's failed, then the developer has to come back, fix the bug, push again, and the whole process starts from the beginning. But if it's green, and we say that Jenkins is green, then we can move ahead and deploy our stuff. So we go for deploying. For deployment, we use our own application called Mission Control. It was actually a weekend project of one of the core developers. This looks like this. I go to Mission Control, search for my project, and deploy the latest version of it into production. But it wasn't always like this. So earlier we deployed with SCP, which went very similar to the thing I was talking before. So this meant that we have the application servers. Someone had a computer, went to the first computer, pulled up the firewall, changed some code, upgraded the virtual env, changed the symlink, restarted the website, allowed the traffic again. Logged out, went to the next server, pulled up the firewall, changed the code, changed the symlink, upgraded the virtual env, restarted the server, and allowed the traffic again. And then went to the third server, pulled up the firewall, changed the code, restarted the server, upgraded the virtual env. So you feel the pain of this. This is very, very slow. This is a manual stuff. And this is still very complicated, so it's very too easy to make a mistake. If I forget to upgrade the virtual env, then the application can be broken because of that. So this was a problem, and usually deploy was a nightmare for people, and not everyone could do it because it needed some special knowledge and some special permissions on the server. So after a few problems and outages, the company decided to create mission control and use Fabric for automate these things. And this was the following. We had the application servers, we had mission control already. I went to mission control, hit the deploy button, and a Fabric process went to the first server, did the same thing, pulled up the firewall, changed the code, but it was much, much faster and much more reliable. And if it was done, went to the next server, and the next server. So it was great because it was easier to maintain. But Fabric is a very, very good tool if you want to do always the same on the same application on all the application servers. But in our case, we were working with virtual env, and creating a virtual env from scratch is usually an expensive thing. It needs a lot of time, and we didn't want to wait 20 minutes on every deploy for that. So we decided to create a virtual env once on the first server and then copy the virtual env to the others. Or actually, we were upgrading the virtual env on the first server and copied the virtual env to the others. But you can imagine what can go wrong here. Then if the virtual env on the first server gets corrupted because of any reason, then the deployment script will slowly copy the bad virtual env one by one to the other servers, causing a pretty huge outage, which can be actually tricky to fix. So even if it's automated and it's great, and anyone can do it, hit the deploy button, any developer, and it's no special sysadmin skills and sysadmin rights are needed. It is still so slow because we go to the servers one by one, and when I have 4 servers, I can pay for that. But when I have 20 servers or more, then it gets painful. And the other thing was that if we didn't have any special logics, we actually changed a smart engineer to a dumb computer with this. So we began to work on making it faster. So we involved S3 to this. And what we did, that we had the application servers, we had the mission control, and when I hit the deploy button, mission control changed a file on S3, which was containing just a file name that was a name of another tarball also on that S3 bucket. And we had cron scripts on every application server running on every minute. They checked every time the content of this file, realized that there is a new version we had to deploy, and they downloaded the tarball and deployed locally, absolutely parallelly. But for this, we need something that uploads the tarball to S3. And in our case, it was Jenkins. So if we go back for a minute, then we added one more step here, which was preparing the application to production. So we uploaded this to S3. And this was great because this was fast at last. And we could do individual deploys. We didn't have to wait for creating the virtual on every server one by one. But there was a problem with this, that we didn't have control about that. If I just realized that I hit the deploy button with the wrong version, I couldn't stop it. Or not just the control, there wasn't a report. There was a cron file that was supposed to run on that server, but if it wasn't running or if the deployment died, I didn't know about that. And this was a huge pain, because with this deployment was a sort of gambling, that I wasn't always sure that everything will be fine or not. So after a few outages and a few problems, there was a point when we realized that we have to create our own smart deployment system that's more robust. And this is called placement. And placement works as follows. We have Jenkins now, and Jenkins uploads the tarball to S3. That's the same so far. But after this, there's a client application, the placement client application, that registers this version to a database that's implemented in Zookeeper. It's a key value store. And we have application server running a daemon, and the application server and the daemon on the application server is always checking the healthiness of the service every minute and is reporting back to Zookeeper. And when I go to mission control and I hit the deploy button, I have a placement client as well, and the placement client will tell the Zookeeper that I want to deploy this version of this service to that server. And Zookeeper will go to the app server, tell that you have to deploy this version of this service. The application server will download the tarball, will deploy it locally, and it's constantly reporting back to Zookeeper. And on mission control, I can see what's happening. And with this is very good because this is a parallel deployment, and I have report about the status of the deployment. And it's controlled because I can say that I want to deploy. I don't want to deploy this. I can say that I don't want to deploy the application to the next server if there is a problem. And we can have special logic here at the client side because what I told you about was only one server. And the strategy how I want to deploy my application is up to me, what kind of strategy I implement on the client side. So I can say that I implement only to one server. I can say that I deploy it to half of the servers or to all the servers parallelly or one by one. It's up to me. So, and there is a special logic we usually use, and this is the canary deploy. Canary deploy works that we have the application servers. I go to mission control, hit the deploy button. Mission control will go to the first server, deploys the new application for the to the first server, and is waiting for the waiting and checking the healthiness of the service. And if the service is not healthy, it does a revert and reports to me that it wasn't healthy, so we didn't propagate to the other servers. But if it was, then it will deploy to the other servers in any strategy. Parallelly, one by one, it's up to us. We usually use parallel deploy for 2 or 3 servers at once. So this is very good because with this we have failure detection. So if the service if we deploy a buggy version of the service, then we can see that if it's not healthy, we don't propagate it. And we actually had a few problems, a few bugs we could catch with this and not cause an outage. And there is an automatic recovery. So with this, if we deploy a broken version to production, even with the canary deploy, we cause an outage, but it's only for one server for 2 minutes. So it's much easier to handle, and it's automatically recovered. So this is how we are deploying now at Prezi. And if I think about this a bit, about these things I was talking until now, then having the code review, having the branches, having the tests, UI tests, the deployment, the smart deployment, canary deploy, with all the safeguards are for making sure or trying to make sure that we don't deploy broken version of the product into production. And I can remember when I was on the technical interview to Prezi, and I was talking to the CTO of Prezi, and after the questions we were talking about the infrastructure at Prezi, and he told me that it showed me the mission control. We had the early version of the mission control, showed me the mission control, and told me that here it is, I can click on the deploy if I want to, because it's that easy. It's an interesting thing to remember that I didn't dare to deploy I didn't dare to touch the deploy button, even if I had nothing to do with Prezi, so I wasn't responsible for that. If it's a buggy code and it's out, then it's their problem, not mine. But somehow I didn't dare to do that. and I think because of two reasons. At first, there is a technical reason, of course, that I know that if I know what's in the background, I know all the safeguards, I know that we have the test. I trust my mates at Prezi that they are smart engineers, and we can solve anything problem we have. So the lack of this knowledge makes me makes a bit unconfident, of course. But there's another thing. There's a mindset aspect as well. So earlier it was so in the first in my previous job, the deployment was always a risky procedure. That I knew that I will do the deploy now, and I hope everything will be fine. And we have to step over this after a while, because the deployment shouldn't be the bottleneck of the development. So the deployment should be lightweight stuff that I can do in an interview, or I can do in a presentation. So for example, if now I go to mission control and load it, and I search for my out service, the authentication service of Prezi, here you can see that it's loading. It shows the version of the service on the servers. It shows where I can revert, and it's checking in Jenkins if there is a healthy new version of the service or not. And if it is, there is a new version of this, the 404. I can just hit the deploy button, and it begins to deploy in the background. So I don't dare to do this, because I know all the system, and I know that this must be like this to dare to deploy. So, and after we deploy an application, we can go and check the dashboard of the services. The dashboard shows a lot of graphs about the services. How do we do this? We have application servers. If we talk about monitoring, we talk about monitoring and alerting as well. So at first, let's talk about the alerting. We have the application servers. The application servers have a lot of checks, and the result of the checks are pushed to the Icinga server. If you don't know what Icinga is a fork of Nagios. If you don't know what Nagios is actually a sysadmin tool for checking the healthiness of the servers, checking the disk usage, the load on the servers, and stuff like that. And you can create specific checks for your service if you want to. So we use Icinga. Icinga has a lot of checks, and if something goes wrong, goes to critical, then we got an email, we got hip chat, or we got a PagerDuty alert. PagerDuty is the service that calls us in the middle of the night if there is a problem. And we also send a lot of data to Graphite. So all the checks don't just produce a warning, critical, or OK state, but they produce a number as well. And we put all the numbers to Graphite. So if we check the load on a server, then we know that if there is a threshold, and if the load is above that threshold, then we get an alert. But every number is sent to Graphite as well. So when we get an alert that the load is very high, we can go to Graphite and check if it jumped suddenly just before, or it was increasing in the last 2 months, just we didn't notice that. So we can look back to the past, and it is very, very useful. And it's true for all of our checks. And these graphs can go to a separate place, to dashboard, where we collect all the important graphs. They are much less graphs than we have at Graphite. Every team collects their own graphs from Graphite and puts in a dashboard to see how healthy their service is. But if I want to check the healthiness of my service, if I want to see if people are registering or not, it's not enough just to check the load on the server or the disk usage. We need application metrics as well. And we do something in Icinga checks, because every service has a health check URL, and we have checks checking that health check URLs, or checking the unicorn daemons running on the server. But they don't check if people are registering or not. So for this, we log everything on the applications. We send the data to a separate log server, we have Logster scripts running there. Logster is a tool for parsing logs, and we can easily specify our own parser for that specific log, and eventually we can come up with the data we want to send to Graphite. So, for example, we parse the log that contains a line for every registration. We collect the data, and we have the number how many people registered in that minute, and we send to Graphite. And after a while, we can have a graph how many people are registering on the service. And we put the graphs to the dashboard as well, of course. So a dashboard dashboards contain graphs from the logs and graphs from Icinga mixed. And this is useful to see if the number of the users registering drops suddenly because of a broken registration of the website. But it doesn't mean that we get alerts. If we just don't check the graph, we won't notice that there is a problem. So because of this, we have special checks in Icinga that download graphs, and Graphite is awesome with providing not just the images, but providing the raw data. So we can get the graph, a very specific graph with special functions on the data, and we can have we can see the exact numbers. And the defined threshold, if it's above or below a threshold, then we get an alert from PagerDuty. So like this. Okay, so this is how our logging system and infrastructure works. As you can see, we have a decent amount of Icinga checks and a lot of graphs we are working with. And this is the pipeline itself. So if you look at this is always all of this is for making sure that we don't deploy a bad version of the application to production. But if we do, then we will notice it quickly, and we can react quickly. So in one sentence, this is a system for avoiding outages. But we do have outages sometimes, of course. And I'd like to talk a bit about how we cope with outages, how we react. So outage means, in our case, then we have a service, and if this service is not functioning properly, then there is an outage. For example, we have a team who is responsible for Jenkins, and if Jenkins is not working properly, then there is an outage of the Jenkins, or a mission control, or the registration of the page. So these are the outages. But there are other outages that are very, very important for us, a special type of outages, and these are the prior ones. Prior one means that if we have this kind of outage, then everyone at the company's first priority is to come and help to fix the issue. And the prior one is, in our case, that if someone goes to a conference and cannot present because of our outage, this is the prior one, the most important thing for us. So how does it look like? At first, someone notices the issue, that the server is down. Notices means, in this case, that usually gets a PagerDuty alert. And when I know that there is a prior one, or I think that there can be a prior one, from that point on, it's my responsibility to alert the others, alert the company. So I go to our HIP chat, or call someone and say that, hey, we have a prior one, or we might have a prior one, perhaps. It's very important. And we alert the engineers, but not just the engineers, but the support team as well, to be able to answer the people, answer the questions of the users. And we alert the social media team as well, who communicate through Twitter and Facebook to our users. And the engineers form a military structure, very rigid structure, and this is very important because this way we can be very, very effective. We always have a lead of the prior one. She is the one who is responsible for making the decisions. She is the information hub, so every engineer working on the prior one, if has some idea what to do, what to check, tells to her, and she decides if we do it or not, or she is the one who knows who is working on what. This person is usually not the best engineer of that particular field, because the best engineers is better if they are working on actually on the console and trying to fix the issue. But this person has to be someone who can oversee the whole system and knows every part of the system. And our first task is to eliminate the prior one. If this means that we shut down the half of the site, people cannot register, cannot pay, cannot check the about page of Prezi, then we do this for making sure that they can log in and they can present. And after this, we bring back the website to full functionality. And when we are at this point, then we know that we can say that the outage is over. So now here comes the investigation part. It's not necessarily that same day. If it was in the evening, in the night, then next morning we come back and a few people who were involved in this begin to investigate, collect all the data, all the graphs, all the log files, everything. It's interesting that even if we cannot find the root cause of an outage at the first day and during fighting with the outage, next day we can have a lot of information. We can get information from the graphs and logs, and we can find a lot of information about our system and about the outage after this. And we try to find the root cause. And after this, we create a document, the so-called postmortem document. Here we talk about the causes, talk about the problems, and we talk about also the near misses. So if I find something during the investigation that there was something that could have gone wrong, but it didn't, fortunately, but it would have been much more pain, then we talk about that and treat it as part of the outage, because it was just a luck that we didn't have this big trouble. And we always talk about the solutions in a meta level. So we don't talk about the bug, we don't talk about the language or the features, or we don't talk about the concrete issue. We always talk about why we have had this issue, why didn't Jenkins catch the bug, why our delivery pipeline didn't work the way to avoid the outage. And after the document, we have a meeting, the postmortem meeting, when we come together and talk about the prior one, everyone who was involved, the prior one, and everyone else who is interested in that. We talk about the processes, not about the bug. We create action items. We use Kanban. Most of the teams use Kanban, so we create Kanban cards. Actual action items, what we want to do to avoid this kind of outage next time. But there is one thing we don't. So the action items are always doable items, and we don't ever say that we will pay more attention. It's not a solution. We won't pay more attention actually. And there's one thing we never talk about, that whose fault was the prior one. And this is it's a very important and very strong part of the Prezi culture, that we don't talk about talk about this. But why? Whose fault is the prior one? So when we talk about this, it's important to state that it's actually nobody's fault, a prior one, because of two things. At first, because a human error is never a valid case. So we can never say that we all know that we work with smart engineers. They don't want to mess anything up intentionally, and we all make mistakes. We all make bugs. And this is an important part of doing a job, of working. And the other thing is that, I don't know if you know this Swiss cheese theory. So imagine a slice of cheese, Swiss cheese, and every slice has holes on it. And when you rotate the slices, you rotate the holes on the slices, and when you get a state where you can look through the slices because of the state of the holes, then this is the outage. And the holes represent a bug, of course. And so usually it's only one person who implemented the bug in the system. There are a lot of things that went wrong, which is a very good thing in the sense that this is an opportunity to to fix a lot of things in our delivery pipeline. So if we, what we don't talk about during the postmortem meeting is that who implemented the bug, or who didn't write the proper tests for the service, or who hit the deploy button, of course. But what we do talk about is why didn't Jenkins catch the process, the bug? Why did the prior one take that long? It's an interesting thing. We always talk about that, how good we were with fighting into the prior one. How could we be much more faster next time if we have a prior one? We talk about the near misses I mentioned before. So just a few months ago, we had a near miss with my team. We deployed something, and fortunately, the whole system was designed to be able to fall back if this component dies. So this component died, everything could fall back, but it was a sort of luck. So there was no real outage, there was no prior one, but we treated that as a prior one. It was a near miss, but we had the postmortem meeting with the investigation, the postmortem document meeting, and everything like at a real outage. And we talk about the successes as well. So when we were improving the deployment system, and we had some outages, not because the deployment system, but we realized after a while that the deployment system worked very well and prevented a lot of things, then we celebrate these successes as well. So this is our continuous delivery pipeline. I hope I could show you how we improved the pipeline and how we changed things during our work days and after outages. And this is something we always change, we always improve. So it was absolutely different 1 year ago, and I'm sure that it will be absolutely different 1 year in the next year. So if I would give this talk next year, I'm sure that I would talk about something different. Thank you for your.
Any questions? Everyone is shy, really? Come on, just one question.
Okay, you showed on one of the slides you had over 100,000 different metrics, right?
Yes.
Do you analyze all of them, looking for anomalies, or do you just collect them to have graphs?
Not yet. I mean, so we have a lot of graphs, but we have automatically. So when we start a server, we get 1,000 metrics from that server, and as a service owner, not necessarily check that on a daily basis. So we don't. We always pick the specific metrics interesting for our service, and a lot of these graphs are for investigations. So to see if something is wrong, then we can use it. So sometimes I feel that we don't need these many metrics necessarily because we never check it. But every metric is useful at once in the future when we have an outage or when we are investigating something, and we were glad a few times that we have these metrics even if we don't check it every day.
Okay, thanks.
Hi, I have a question. How often do you run your Icinga tests? Once per minute or once per 10 seconds? How often?
They run once per minute. So, and these are a huge amount of test checks, and so after a while this was a problem for us. So at about 25,000 checks, the Icinga server got problems. So now we changed to a push model, So all these tests run in every minute from a Chrome file on the server and push the data to the Icinga server.
Sorry, are you not afraid of switching between old functionality to new functionality? Because you told us that you merge into masters every day or every few days,
yes,
and switch between functionalities.
Yes. Sorry, and what was the question?
Are you not afraid of don't test in master the functionality? Because it doesn't make a change if you merge after a few weeks with switching your flag in the configuration, or just putting in, or just merging after a few weeks, or switching. It's not a change, because you don't test your new code in the master, and you don't test the others' code in the new branch.
Mm-hmm. We do test with the new version. So we can run the unit tests with specific feature switches turned on. So at first we can write a lot of unit tests checking my code, even if it's not wired into the production code. I can write a lot of tests there. We can write tests where we can say that I want to do this check and I want to turn this feature switch on only for this test. So I can write integration tests inside the application as well, and we can do it on the UI test as well. So we can tell to the testing framework that I want to go to the website, log in, create a presentation, do this and that, and with this feature switch turned on. So we can test our application before putting it into production.
I have a question about slide where you present that you changed approach to your branches from feature branches to the master. Can you give the timeline of those changes, and can you also give the background on how many developers are there in your company? So just to give a scale of this.
So when we changed from feature, what was the amount of people of having this with this scaling issue? So in our, it was actually changing from feature branches to merging to the master was slightly at the beginning of the company. So there were only it was actually before me, and as far as I know, it was with 40-50 people. So, but 40-50 people working on a branch and having merging issues was already a big pain.
You mentioned before that you're planning to use Docker within your environment. So my question here is, what's your current state in Prezi of using the containers? And are you planning to use Docker within Jenkins to create test environments? And what else? Are you using it in some web environment for testing or for something else?
Now we are using Docker only for testing, and actually not for backend testing right now. So we are as you know, we have separate implementations of the Prezi application. We have an iPad, an iPhone application. We have a Flash version. So different teams have different needs for the environment, and this was always a pain when we fired up a Jenkins slave, and for the Flash testing is something absolutely so they need absolutely different things than the iOS developers, and this is where Docker helps us right now. So we don't use it in production just to be able to separate the testing environment for different platforms.
I have a practical question about these feature switches that you've mentioned.
Yes.
do you have any statistics on how long does it take until the implementation of the old feature actually disappears from the code? Or how many, well, relatively how many of these switches stay for the code longer than you would expect?
Mm-hmm. Yeah, that's a very good question. Thank you, because the feature switches is something that needs maintenance. So when we put, so there are two things here. At first, that we have to put to the right places and not to everywhere in the code, only into one or two places, and that after a while we have to clean them up. And this is usually something that always is missed. So people don't like to clean up the feature switches because it's typically much later than the releasing of the feature, because for a few months we think that we can even turn off it if it turns horrible. So this is why we leave it there, and when we come to the point that we had to clean it up, then we are already working on something completely different. So this is the problem, but we have a team who is responsible for feature switches. Not only for that, but feature switches too, and they just began to celebrate the anniversaries of the feature switches with cleaning them up. So they are the people who are nagging people to clean up your feature switch. So now we have some process for cleaning up, but that's an issue for sure.
I have a question. In case of an outage, do you roll back your application to some previous version?
Mm-hmm. This is always depends on the case. So when we see that it's because of the application, because we just deployed and everything broke, it must be this, we do a revert. But it's not we don't have this kind of process, what we do at first in technical level. So if it makes sense, then we do a revert, right?
Okay, and do you need to struggle with some database downgrades in this case?
We don't do data migration with deployment. Okay. So we always change. It's not very often that we change the database, and when we change, we always do the way that we change the database at first, and then we deploy the new version. So the old version can work with the new database as well. So, but when we need some data migration, then we put this logic into the application to be able to migrate the data slowly and be able to revert that.
You mentioned that you are using Icinga
yes.
for checking for something on the server side. But my question is, are you using any RUM monitoring on the client side and connecting it with Graphite? Or?
I'm not absolutely the person on this field, unfortunately. But so the servers are not communicating to anything else in this sense, just to Icinga, and so the infrastructure is always about the checks, and it's actually not always about Icinga. We have our custom scripts that produce the number, and we have a wrapper over them for Icinga. So this is an important infrastructure element that that there is only one way how we manage the checks.
Okay, but my question was about the monitoring on the client side, some JavaScript monitoring or something.
Oh, I see. Okay, sorry. Yeah, right. So on the JavaScript level, we use logging as well. So they send log to these servers, and we have a log service that gets all the log files or the log lines, and we use the same Logster, Graphite, dashboard pipeline for having this kind of logging and having these analyses. Yes.
I have a question. How long it takes from code is merged to repository and is go to the production, all the steps?
Mm-hmm. It heavily depends on the service. So we have this huge service, this huge repository I was talking about. And because it's big, it involves a lot of tests, a lot of UI tests and everything, and the UI test is always slow. So typically, if I push something into production, then having the whole Jenkins flow needs about 20 minutes in our case, and the deployment of this is also about 10-15 minutes. But there is always so when we always run one pipeline from one service. So when I push something and Jenkins is already working on something, then on the same service, then I have to wait until it finishes, and my version gets started. So it can be even more. And if we have sometimes flaky tests and we have infrastructure trouble in Jenkins, then it can be a bit more.